So we discussed that we have a node. Node is what? Physical machine. And then we have our pods. Maybe an app pod and our DB pod. So tell me what is attached, how the pods communicate. Mohsen, how the pods communicate?
Service,
IPs.
ingress,
The pods communicate through IP addresses. The basic thing is IP address. The pods communicate through IP address, correct? Let's say it's correct. But we don't use IP addresses, we use services because when the pod is destroyed, it is recreated. Because Kubernetes is a self-healing cluster. So, but the IP addresses change very frequently. So we do not use IP addresses directly. So for that, we have a component called service. And service is attached to this pod. Right? And service is what? A load balancer. It's a static IP address. We now communicate using the service name, and service knows what IP is attached to what pod. If you have 10 replicas or 10 pods, so the service will know the IP addresses of all the pods and it will communicate with that. So this load balancing is done through service module and it does it automatically. Okay. And the service listens on IP address and port. And now if we have app service and we have DB service. So this pod will communicate with this pod using this service name. So if you remember, I told you that service is the IP address and listens on port. But if we want sorry, if we want that our app has some URL like abc.com, then we use the module ingress. So the flow will be, and further we discussed internal services and external services. So if anyone can explain me what is the difference between internal service and external service? There is no point of going into lab if we don't have these concepts. Otherwise, we will be way more confused. So can you explain me the service types? Mohsen? Anyone? Okay. So we discussed we have a module called ingress. Then we have service types, external and internal. The external service is which is exposed outside so that everyone can connect to that service, and it is exposed through IP and port. I should not write it here. An internal service is like when this app is communicating with this DB, it is communicating internally. And we don't want to expose our database to the world. So app communicates with DB through internal service, and the world communicates through our application through external service, and external service talks to the ingress. So the flow is whenever client request abc.com, the request first goes to our ingress. Ingress knows what backend external service I need to forward this request. So it receives the request abc.com, it forwards it to external service. External service will forward it to the your application, and on the back end, your application through internal service will pull the data from your database. So is that clear? I think you should unmute your mic so that I know if you are getting it or not.
Yeah, Jishan bhaiya, you can continue. Keep yeah, just listen. Because
Okay.
I was staying on the unmute, I mean mute position.
Okay. So actually we discussed everything, and
Yeah, I mean I forgot
every
it honestly.
everyone forgot why we discussed everything and what we discussed.
Yeah,
So
too many terms and to remember and which term belongs to what.
okay.
So that's the only thing.
And there was a config map. Anyone remember what is a config map?
Blank.
Blank. Good. Okay. Actually, what is a config map? We attach environment variables like in our example, let's say our app needs to talk to this DB service, and somehow the DB service name is changed, or this DB service, I mean, this is a shared database and many pods needs to connect to it. So what we will do is we define that external database, or what you say that in our application, I have a connection string, my SQL connection string, and I have defined a database service name in our connection string. And if the database service name is changed, so what we need to do is we will change the name to the newer name in our connection string. You know, in our index.php, we had a DB connection code which connects it to the database that the host is this IP address or this name, and the username is test, the database name is example, password is abc1234. So I'm talking about that connection string. So if the database URL or the database host name or the database service is changed, you have to change it in your application. Then you make a container out of it. That container will be tagged. It will be pushed to the repository. And from the repository, it will be downloaded in the Kubernetes again. So to avoid that, we define external parameters in config map. So if anything changes, we tell config map the backend is this DB URL. And we can use this config map in our whole namespace. Like any other configuration can take this value from this config map. Plus, we can define username, host name, passwords in config map, DB URL, let's say. So we can define everything in config map. But I told you there is a problem with defining username and passwords in config map. And what was the problem? The problem was everything is written in clear text format. The password, the DB URL, the username. So there is another module that is called secret. And we define the username, passwords in this file, and they are encoded in base 64. And we call these parameters wherever we want. At least tell me what is replica set. So the replica set is how many replicas of your pod you want to create. You define replica set value as 10, and 10 pods will automatically be created and load balanced through service. And if you reduce it to 2 or 1, all the pods will be destroyed, but just changing the value of replica set, and it will come down to 1. And load balancing is already done through your services module. So with config map, secret, and finally we learned the deployment. That deployment is the blueprint, or it's the configuration file through which we control everything. How many replicas, what should be the name, what should be the service, what port will be exposed. So everything will be done through the deployment. I am pausing here because I want to
network.
ask you, are you getting
Your
it?
voice is not audible. Like I
Okay,
don't know
what?
what others. 10 seconds, maybe 10 or 12 seconds.
Any problem with anybody else? Should be. Okay, now you are listening it, Mohsin?
Yeah, listening. So I just
So
missed that replica and the blueprint.
yeah, I was talking about replica set. So
Yeah, but
replica set is you can increase or decrease or scale up or scale down the number of pods or the number of replicas through replica set. If you define the value as 10, the 10 pods will be created and load balanced through your services. And if you reduce it to 1, you have only one replica available. And the deployment is the blueprint of your complete configuration, that what image you are using, what services are using, what port you are exposing, and everything is done through your deployment configuration file. So any confusion till here? Because I think we should touch a little bit of the lab, and I will go very slow because I realize that
The theory part is difficult. I mean,
so
going
if
a bit
if the theory is
theoretical.
difficult and the concepts are not clear, then we cannot perform the lab. So I am sharing the screen.
Yeah, we can relate lab words, those commands to this terminology. That is very new to remember these things also. Can we do lab like that? If this is pod, this is replica set, this is the configuration.
Yes,
This is
actually I have the, let's say I have, where's the project one? Anyways, more. I told you in the start that the master node has an API server and it validates every request, every configuration through that API server. And we define the API version, and we have different APIs for deployment. We have different API for network, services, secret, config map. We will see everything in detail. So first, we define our API version, what we are going to do. The second thing is the kind. It's the deployment. The metadata. It's the syntax of our YAML file for Kubernetes. So we can name it Nginx deployment. Okay, this word Nginx deployment or this name, we can do anything. But if we are deploying Nginx, so this should be Nginx deployment. If it is your app, then it should be your app name dash deployment. So that when we troubleshoot it, or so it will be a way more easy. So these labels, just ignore this label right now because these labels, okay, leave it. The specs. In the specs part, this is your specs part. I have said I will make 2 replicas, leave match labels, and this template is the container engine. I am saying that start a container Nginx with Nginx version 1.22 or colon latest, whatever latest is available. And we know Nginx listens on port number 80. So let's say kubectl is the command to execute everything. That's why Mohsin has just downloaded kubectl, and in Windows he will be doing it. I can show some examples in minikube also if you have any problem. But this is the command kubectl. First of all, get nodes. So I have a master node, which is a control plane, and I have 3 worker nodes. So my cluster is 3 worker nodes and 1 master node. On minikube, you have master node and worker node roles. They are on the single VM on the same machine. So I have different environment. I have a cluster running. So
We can do that setup. Can we do that at our end?
Yes, I have just told Mohsin how to do it. And if you have any problem, I have shared the links yesterday in WhatsApp group.
Minikube or any other thing?
Minikube.
Okay.
So you can use
Is
Minikube.
it is something like single node cluster, right? We
Yeah,
can
it's
do
a single node. Yes, it's a single node cluster.
but
And
node 2, node 3, how we can do that? Node
yes,
2, node
that.
3.
So you want me to you want to know that you can deploy the whole cluster. Okay, we can think of it, but not right now.
Oh, okay.
I mean, these are
Because
the
that
these are the
yesterday
VMs.
when I came to know that it's a single node only. So that's what I wonder how you did. It's okay, you continue.
Ah,
Thank you.
so it's a 3-node cluster, and yes, and what I can do is kubectl get pods. So in our namespace, we don't have any pods, or what can I do is I can do all. So we have nothing available except this default Kubernetes service. So if I want to apply kubectl apply -f nginx.yaml. So my deployment is created, and let's say kubectl get pods right now. So I have my pods running. I have get replica set. So desired to, current to, ready to. And this is our nginx deployment. So our 2 pods are running. And if I go nginx.yaml and I say that I should have 4 replicas. So it's container creating. So the status is 0 by 1. I mean, it's in the process. At it will be done in few more seconds. Yep. So we told the deployment that create 4 replicas, and it has created it just like that. And if I want to say that the replicas are, I want to have just 1 replica. So I have 1 replica running. So that's how quickly it can create or destroy a container.
Yeah, this makes more sense because it's taking not so much time to understand than theory.
But theory is very important.
Yeah,
How do you know that what's a replica set
Ishan,
is?
can you show the config? I mean,
Nginx.
kubectl config view. I want to see the cluster config. Config space view. explain this? If you know.
Okay, we will discuss these things later. First, we
Okay,
should know
okay.
what our YAML file is. Leave the cluster right now. So this is our Nginx deployment. And if we want to remove it, kubectl delete -f nginx dot. So kubectl get all. So everything is destroyed. Now I can share one more thing.
You mean that 4 parts, everything gone? Earlier we created.
Sorry?
The 4 parts we created, right? So those all gone, right?
The pods?
Yeah.
Everything is gone because I have deleted a deployment. So I
So
have
do we
this.
need to stop before delete? No need to stop?
No.
Okay.
Can you see this image? Yeah. So I have this Nginx YAML file which I have just created,
Okay.
and there is our service configuration file. I have created it separately. We can define it in the same Nginx YAML file. But I am defining everything separate so that the concept is clear. So if you can see the difference, API version apps, API version v1, and the kind is deployment. Here the kind is service. The service has its own metadata and configuration, and the deployment has its own variables, configuration, metadata, and specs, deployment, etc. So the metadata is what? Here we have defined metadata that it is our Nginx deployment. I can call it Nginx service because it can make sense that it is a service and this service belongs to Nginx. So here in specs, we tell how many replicas and what image I use for the pod. In the service, what the selector is. The selectors are and labels are used to communicate to the pod. Like selector will select app Nginx, and we have configured our app name Nginx in our deployment. So through this, the service will know that I will connect to this pod, and the ports for communication. This target port is the port of the container. Container port is listening on port 80, so the target port is port 80. And this is the service port on which we want to expose our service. Any confusion in this? Or should I run it? So we define a service, we define a deployment of our Nginx, and I told you the service will act as a load balancer, and it doesn't matter how many replica sets are created. They will be created with this Nginx tag. So you can say that labels are tags attached to those pods. And that tag can be called or selected through this selector, and that's how it is done. That's how it communicates. So if I go to the command line again, I have kubectl apply -f nginx dash service and nginx dot yaml. So we have nginx service running. So nginx service and endpoint is our pod or the cluster. So this nginx service, let's say nginx dot yaml, and I can say that there should be 2 replicas, so it will be more visible.
Okay.
So now if I describe that service, we have 2 pods running, right? And both are listening on port 80. And how do you know that these are the real pods, or are they the pods? kubectl get pods -o wide. So these are our 2 pods. One IP address is 10.2442.25, this one, and the other is 1.22. So these are our 2 nginx pods, and the service is communicating with these pods. So if there is some issue with your configuration, you can describe a service, and -o wide gives you some external columns and information. So now if I do kubectl get all, so we have this nginx service, we have this nginx deployment, and these are our 2 pods, and this is our replica set state. Are we getting it or not? Mohsin,
Yes, I'm here.
are you getting it or not?
Yeah, I'm making notes. Actually, I'm just focusing.
Okay, you're making notes, but I think it is more important
Yeah, I mean,
because the
I'm
recording is
giving-
available. So
Yeah.
again, this is our kind deployment. In deployment, we just tell the name of our deployment,
Mhm.
and in labels, these labels are attached to our parts. So this app is either nginx, it can be my app. But if you define my app here, you will define my app here, my app here, my app here. And the my app container image may be whatever the image is. So this part, this highlighted, or this the part in the red box is your kind and metadata. The specs part, which is highlighted in green, it is telling that the specifications of the pod which will be created, like it has how many replicas. And then we have template, And template is what? It is highlighted in pink box. I can zoom it a bit. So this template has its own specs. So this specs is like these are two configurations. It's a configuration and there is further configuration inside that configuration. The template, we tell the metadata and the labels that app is Nginx, and this blue box configuration tells specifically about our Docker container. That container name should be Nginx and the image should be Nginx or whatever image we are using, and it is listening on port 80. So these are the basic two main categories, the red and the yellow. And there is a third category that's called the status. So we have our status attached with our file automatically by the Kubernetes, and that goes into the key store so that the Kubernetes cluster continuously monitors what is desired and what is available. And through that status section, it can manage that if our pod is destroyed, it can see that the actual status was there should be 3 pods and 2 pods are running, so it will create another pod. So that third configuration is automatically attached by Kubernetes. Okay. I was thinking that initially what we did was we had Apache PHP MySQL deployed. On Apache PHP, we had our application, which is right now available on Docker Hub. We all know that. And we then can install MySQL or MariaDB. We can configure PHP to manage the database. We did it the traditional way through Ansible, through Dockers, and I want to do that lab through Kubernetes so that we know in what technology how we proceed. So I can share. So I have created my project 2 in which we will be using config map, MySQL, we will be using secret, then we will create a MySQL service, we will do the PHP deployment, PHP admin, and we have the PHP my admin service. So I have taken a screenshot of the configuration and let's see. Yes, I have this available and I can share the screen. Is the text visible enough?
Yeah, we can see.
So again, first I will discuss service, MySQL service. The service is like API version, v1, kind service, metadata, MySQL service, selector app MySQL. So I will connect to this MySQL app. It is the same as before. Then the template, I told that it's the pretty standard and basic stuff. The container I am using is, I am calling it MySQL, and I am using MariaDB latest image, and we all know that MariaDB or MySQL, they listen on 3306 default port. Okay, if you guys remember, Docker Hub. So we will search for Maria, AR, MariaDB. So we did it in the past that we have our MariaDB user, we have MariaDB password, and MariaDB root password. These are the three environment variables which we use to communicate to our we set the root username password, we set the admin username password. So it is the same MariaDB user, MariaDB password, and MariaDB root password. So when we are defining a container, even in Docker, we have told that these are the username passwords and set these environment variables while configuring this container. So what I am doing right now is I can either define the value here, or I can take the value from secret key reference. And the secret key reference is, this is our secret key reference. I have created my SQL secret.yaml file, and the kind is not service, the kind is secret. And I am defining this as a MySQL secret. Leave the type opaque, it is default, and MySQL admin user, the password is defined as base64 encoded. MySQL admin password, base64 encoded, and MySQL root password, base64 encoded. And what we can do is, we have called this my secret. I have called this I have defined it. The metadata name is MySQL secret. So I can call this MySQL secret, and then I can use the values from this secret file. So MySQL admin user. So I am sending the value of MariaDB user from this MySQL admin user. The MariaDB password, it's MariaDB admin password. I have defined it. Actually, these variables that what is displayed in blue, you can name them anything, but you can call them the same way here. But this is very strict. MariaDB password. This is your container requirement. These are the environment variables. We are putting the values, fetching the values from secret and putting it here. And then the root password, finally, the root password. And I can show you that. Let's say I can go on a website. Wait a minute. Share screen. Base decode base 64. So I have copied the encrypted content. And you know what is our root password? We used to type Jazz82. So if we decode it, it's Jazz82. What is our admin user? I can copy from the file and decode it, it's admin. So admin user is admin, but in secret file, it is encoded, and you can do the encoding through command line, or you can use this online website if you want to encode anything. I mean, if you don't want to decode. And code base 64. So if you type JAZZ82 and you can encode here, and you will get AMF 6E and JGY, and it is the same which is written in our file. I can share that. So it is the same AMF6E JGY. So that's how we encrypt our username passwords and we call them in our variables. Any problem till here? Because the next image would be a bit more complex. Share. This is the second image in which we will be doing the MySQL. Okay. MySQL deployment, MySQL service, MySQL secret. Then we will be using config map, phpMyAdmin service, and phpMyAdmin deployment. And then it will further grow when we will add our Apache Apache container, and then we have our Apache service and that ingress for that Apache. So what I